Folks, in today's episode, we're going to take a look at a very misunderstood company known as Tesla. All right. So, first of all, most people think of Tesla as a car company. Okay. Um, the thing that I think misleads many people into believing that Tesla is a car company is that, yes, they do manufacture electric cars. Okay. But the core technology that's under the surface is completely different than a traditional car. And so we're going to look at the details behind that in just a second. And I'll try to give you some context and explain why that is and provide some foundation for why I believe that this company is going to transform the entire industrial method of transportation. Okay. So we're going to look at the details here. And we're talking about a company that's founded in 2003 by a group of Silicon Valley entrepreneurs, which include Elon Musk. At first, his involvement was more as an investor. Okay. He would provide, consulting type input into their initial project. He eventually took the company over. And the thing that I'd like to try to emphasize that makes this company from its very DNA so completely different than any other uh, automotive company or any other company in the transportation industry is that it's at its very core, the paradigm for the thought about what transportation should be like is more based on a computer or a cell phone type of approach to transportation rather than an internal combustion engine vehicle legacy automotive manufacturing paradigm. So just a completely different way of thinking about how we move people and objects from point A to point B. They have multiple business segments. Obviously, their EV manufacturing business is most well known. By the way, this includes things like semi trucks, cyber trucks, and then they have the very popular cars such as the Model S, the Model 3, the Model Y, I think is the number one selling brand car in the world right now. Battery storage products. Okay, we're talking massive grid scale um, lithium ion battery packs that actually help store energy during off peak hours and make that energy available during peak hours. And it dramatically improves the efficiency of the operation of the fixed physical infrastructure, the power plants that are in a electric grid utility. And this is incredibly important and very valuable technology in the year 2025 as we move forward with the AI data center rollout. There's tremendous stress and demand on electrical energy production worldwide. And with this megapack solution, then you can get 35, 40, 45% more electrical energy out of your grid than without Tesla's megapack battery storage product. But this is only about 10% of their revenue right now, but it's growing super fast. They have a supercharging network nationwide. We're talking about a company that's not only vertically integrated, it's almost as if you had, say, General Motors, if General Motors owned all the gas stations in the United States. Okay. Now it's not quite as simple as that because people do charge these vehicles at home. But if you are traveling and you're in any type of EV in the United States, all of the manufacturers have standardized on the Tesla North America charging standard as of a few years ago. And then they have a very, very interesting product line that they're in development on called humanoid robotics. Okay, we're talking about human form robots that can essentially replace human workers in for most types of jobs. And this is still in its early stages, and I don't expect this to be a big moneymaker over the next couple of years. But going forward, this has probably 10 to 20 times the economic growth potential of any other business that Tesla has, and actually has the potential of being one of the most valuable businesses that the world has ever seen. All right. So going back, core technology of the company, we're talking about automobile more like a cell phone, okay? A central processing unit chip that has wheels on it, okay, that move the vehicle from place to place, kind of like how, if you got your cell phone on vibrate, there's a little vibrate motor, there's a speaker on your cell phone. You are able to take data, centrally process it, display it, actuate things like I said, like the speaker, the display, the vibrate motor, those kinds of things. I want to try to create a framework for understanding how different this is from a traditional car. The U.S. automobile industry essentially grew out of the cast iron stove and the cast iron parts industry that already existed in the city of Detroit prior to the formation of companies like General Motors and Ford Motor Company. And it was this legacy technology of being able to cast metal that allowed cars to function in terms of the engine blocks. So to this day, the name of companies like Ford, it's the Ford Motor Company because the motor was the core technology. It was General Motors, right? The motor was the core technology. With Tesla, the motor really isn't the core technology. The core technology is the computer, hardware, and software that is inside that's controlling the whole thing, okay? A traditional internal combustion engine vehicle does have computer-ish types of elements to it, but these are things that were added in the 70s, 80s, 90s, little chips that might control the seat motors. There's a chip that controls the motor that moves the windows up and down. There's chips that control the entertainment, radio, stuff like that in the car. The windshield wipers have their own chip. It's very different than a CPU-based vehicle where basically everything is controlled from a central processor. And because everything is controlled from a central processor, they can do over-the-air software updates, and they can update and actually fix problems that might occur that may come up in a Tesla vehicle using software updates instead of having to take a car into a shop. So vertically integrated, the thing that is just is mind-blowing from if you look at Tesla from the vantage point of a legacy automobile manufacturer is that you've got a CEO in Elon Musk who has undergraduate degrees in physics and economics and is a very good engineer himself. He's actually steering and directing the core technological milestones. So he's currently working on their AI chips. They design and have manufactured their own AI chips that control the full self-driving features. And so very hands-on CEO that really gets into the nuts and bolts of the engineering and design of and providing the vision for this company. Legacy automotive manufacturing is completely different. Okay, we're talking about very standardized types of technology because we're in the year 2025. We've had assembly line manufactured internal combustion vehicles for about 100 years. So we have tier one suppliers, we have tier two suppliers, tier three suppliers in legacy auto, and they all feed their components into basically companies like Ford and GM and Stellantis are kind of like they're assembling all the components from all these other disparate companies, and their engineers do engineering work by flipping through catalogs essentially and picking out a part from the Bosch catalog or picking out a part from the Magna catalog and integrating that into the vehicle rather than doing the core engineering themselves. Once again, I can't explain how different this paradigm is from an internal combustion engine vehicle standpoint. I would say a traditional legacy automobile is more similar to a horse than it is to a Tesla. And here's why. If you boil it down to the basic physics of how a horse works, you're talking about a biological machine that has inputs of hydrocarbons and converts those hydrocarbons into mechanical motion and can move a person on, with a carriage or, riding on a horse from place to place with about 10 to 15% efficiency at converting those hydrocarbon feedstocks into mechanical motion, whereas an internal combustion engine vehicle is not that much more efficient than a horse. All right. Most of the energy that goes in the car is like wasted in the form of heat and just friction and noise. And so with an internal combustion engine vehicle, you're talking about 30 to 35% hydrocarbon energy conversion to mechanical motion. We're talking about internal combustion engine vehicle assembly process, 2,000 to 3,000 different moving parts to make an internal combustion engine vehicle work. Things that spin around, things that move up and down, transmission mechanisms. And every single part is an opportunity for failure. It's an opportunity for something that can wear out. And it adds complexity and cost to the manufacturing system. In comparison, a Tesla type of car converts 75 to 80%, 85% of the electrical energy that goes into mechanical motion of moving it around. There's no oil changes. There's no transmission fluid flushes. There's no radiator fluid flushes involved. There's only 10 to 20 moving parts. And these vehicles, because they're electric motor based, have maximum torque at 0 RPM. So side by side, acceleration performance characteristics are way better with a Tesla than with an internal combustion engine vehicle. So this company is in a transition phase, and here's where I think the big opportunity lies. They're using what I call a razor and blades type of business model. Most people don't understand this, okay? Legacy automobile manufacturers, they make their margin off of selling the car. And yeah, Tesla still makes, they make money off of selling the cars. But more and more, what's happening is that they are making money off of the software that runs the full self-driving capability of the car. And if you've been following the scaling laws for how AI has been improving, doubling in in efficiency and ability about every 5 to 6 months. They're riding this AI growth wave with their full self-driving technology to the point where I believe by putting together a number of different data points that I've been following, I think full self-driving right now is about 3 to 4 times safer than the average human. And it's doubling in safety and efficiency about every 6 months. So it's it's going to become almost criminal to not allow people to drive around with full self-driving because it's just pure and simple. It's going to be saving lives. Okay, 40,000 people die every year in crashes in internal combustion engine vehicles, and a lot of it has to do with distracted driving. And we can take that number and get it pretty close to zero if people convert over to using full self-driving type of autonomous vehicle technology from Tesla. Here's a chart showing their global vehicle deliveries, and the thing I'd like you to key in on this is that they have a pretty significant, like a 2 million vehicles worldwide at least that have been deployed, and all these vehicles via over-the-air software updates are able to access the latest full self-driving software. So they're all going to be able to access the technology where the people will be paying like a monthly subscription to have the car drive them around automatically. And so we have this massive, massive conversion of human labor of people having to pay attention with a steering wheel and traffic and the stress of driving the vehicle themselves, and the AI is going to be taking care of this. So they do have, like I said, about 10% of the revenues from their Megapack battery energy storage products, and the demand for this is exploding right now, as I said, with huge stress that the AI data center build out is having on the grid. Then all the utilities are going to be scrambling in order to buy their lithium ion based Megapack battery storage units, and they have software built into these things that automatically regulates and feeds the energy into the grid at the right time, and it can store the energy at the right time. Okay. So if we look at revenue growth rates, this is really interesting, and this is a big part of the opportunity, is that we have 5-year revenue growth of 32%. The past year, only 0.9, right? And then the 5-year earnings growth rate of 24%, 1 year minus 52. And this is where people that are Wall Street analysts are just completely confused. Because if you look at this through the lens of the types of metrics that Wall Street analysts use for analyzing the legacy auto companies, this company looks like on paper in their spreadsheets, it looks like it's doing terrible. Okay. And so, but in reality, if you look at the core metrics that are driving the intrinsic economic development growth of this company going forward, it's just mind-blowingly bright future in front of it. This is the key metric right here. Full self-driving miles per intervention. An intervention is when a person is driving the car, they're still kind of responsible for supervising the AI, where a person feels like they have to intervene in order to prevent an incident from happening. It could be, tapping on the brake pedal. It could be making an adjustment on the steering wheel. So about every 7 or 8 months, they come up with a new version of their software. Version 12 was under 200 miles per intervention, and then we're talking 400, and then most recent version that was just released, version 14, we're up to over 1,500, and we're only just beginning to roll out version 14. By the time we hit version 15, I believe, which is probably within the next 6 months, Teslas will be able to drive 10, maybe 12 times better than the average human. Okay. And people are already making reports that Teslas have almost like superhuman driving capabilities because there's 8 cameras built in that are absorbing light, basically photons in. Um, you know, Cars that are on Tesla full self-driving are able to steer around potential, you know, problems. I mean, if there's something in the road that a person might not be able, if they're driving at night, especially if there's something in the road they may not see, or if the wind blows something in front of the car really quick, the reaction time of the full self-driving is so much faster and better than a human at this point that people are reporting that it's it's already preventing them from getting into crashes compared to what would be occurring if their cars were being driven manually. So vehicle deliveries, we can see the numbers are going up, 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 and we've got this little plateau out. Last year, a lot of this has to do with the fact that they've been plowing a lot of their time and energy into the full self-driving, and they're gearing up the manufacture of something that they call their cyber cab, which is basically a simple car that's a two-seater that they can manufacture for about $20,000 a piece. Okay. And once the cyber cab comes out, then they will be able to distribute these things throughout all the cities and metropolitan areas of the United States, and be able to move people from place to place with basically just the cost of the electricity that's needed to move a person from place to place. By the way, right now, an Uber costs about $2, $2.50 per mile to move a person from place to place. Most of that is because there's a human driver. Once you have like a cyber cab type of situation, that cost is basically, for the most part, the cost of the electricity. And we're talking about maybe 15 to 20 cents per mile to move people from place to place. So they kind of like, it's almost like they own all the gas stations in the US right now when it comes to electric vehicles, because they have the supercharger network. And the legacy auto companies, Ford, GM, Stellantis, the Japanese company, they all tried, to work and create a standard that was an alternative to Tesla. The technology didn't work. The reliability was terrible. There was a lot of government money that went into a competing network from the Inflation Reduction Act during the Biden administration, and basically almost no government charging stations have been constructed, even though billions have been spent. Meanwhile, Ford was the first major auto company to give up on this and to standardize their electric vehicles on the Tesla North American charging standard. And when they did that, then GM and everybody else fell in line, Rivian, et cetera. They all have. So they're all going to be paying a little premium on the cost of charging. If you're out on the road, if you're traveling, if you're not in the Tesla network, you're going to pay. Tesla's going to make a little bit of money off of everybody that is using their chargers. So we have robotaxi networks in 10 major cities by December of this year. It's already in Austin and San Francisco, and they're rolling it out to other cities. I expect the robotaxi network to be nationwide sometime in 2027. I expect autonomous driving to be an expected feature in all automobiles by 2030, just like we now expect power steering to be part of cars and, headlights to be part of cars, electric headlights are a part of cars, then it's going to become, in a sense, just something that people are going to expect to have. This is creating an interesting situation where the legacy auto companies are going to be put in a situation of either having to license Tesla's full self-driving technology and pay a little royalty off of their use of it, or I think they're going to go out of business. I don't see any choice. I mean, at one point in time, people referred to these cell phones called Blackberries as crackberries because people were so addicted and they had almost all the cell phone market. And then the iPhone comes out and blew them away. All right. Research in motion is almost non-existent. And then Kodak could have been the king of digital cameras because they had the first digital camera technology. They set that aside and they didn't develop that, and Kodak almost completely disappeared. The current CEO of Ford Motor Company, Jim Farley, was interviewed a couple months ago, and one of the things that he said in this interview was really interesting to me. He said, "People enjoy the challenge of driving cars." Okay. I'm like, what? Really? I mean, if you had the option of being able to manually drive it or let the car take over every once in a while, I think pretty much everybody would like to have at least the option of letting the car take over every once in a while. And it would be a lot less stressful because then you could text and you could, close your eyes and rest. And I just think that Jim Farley I think they're still a little bit like in denial about what's going to be happening going forward. They're making very good profits off of their pickup trucks and stuff right now at Ford and GM and Stellantis. But that situation is going to change when people start to pretty much universally demand that they have a car that can drive itself. Okay. Um, Brand damage occurred in this year when Elon Musk got involved in the Doge government efficiency initiative and tried to reduce the waste and the fraud that was occurring at the federal level spending. And I'm sure that that brand damage still exists and that there's a lot of people that would not buy a Tesla right now. However, brand damage tends to fade over time, especially when the economics of the decision to make a purchase, um, you know, outweigh, the, um, you know, the psychological issue of dealing with the company. I mean, there's been tons and tons of car companies that have had terrible public relations disasters in the past. I mean, VW had a huge problem with cheating on the emissions testing system for VW cars, and there's been all sorts of recalls and stuff like that, and this brand damage does tend to fade over time. So I to summarize, the opportunity for this company is tremendous just with the full self-driving technology. I think we're talking about perhaps increasing the earnings by a factor of 20 over the next 5 years just from that technology. And then here's the other thing. Elon Musk boils everything down to first principles type thinking, meaning he takes it all the way down to the laws of physics and then he works his way up into the technology, into the business use case. And he realizes that a humanoid robot is also a lithium ion based device that has actuators, meaning motors, that is software controlled, And the similarity between that and a Tesla is very, very high. And so they're working on their Optimus product line, humanoid robots. And although it's not 100% same, okay, the training that's involved with training cars to be able to drive themselves is very similar to the training that's involved in training a humanoid robot to perform useful work. So I do anticipate that the humanoid robots will be a thing probably 2030, 2032, 2034, somewhere in there. And then once that begins scaling up, we're talking about another increase in economic gain by another factor of 20 to maybe 30 on top of the 10 to 20 times increased uh, earnings and revenue that we're going to have as we roll out full self-driving. So I think there's a very long runway for growth. Tesla happens to be the company that I have the largest investment in. I feel that I understand the company fairly well. I live in Dearborn, Michigan. My whole life, I've kind of been tangentially associated with the automobile industry, with Ford Motor Company and uh, existing in Dearborn, and so yeah, I that's my largest investment, and so I just wanted to share these ideas with you. Of course, as always, I'd like to caution everybody. This is a company that is involved in great technological transformation and change, and the stock price tends to be very volatile. But if you think in long time scales, then I think the opportunity is very good. My risk tolerance is very different, of course, and I've mentioned this before, than anybody else. So you need to do your own research on this and see if it matches up with something that that you think is worthwhile. So, all right, lots of stuff. Thanks for taking the time to check out this episode on the Tesla company. I'm Jeff Whitaker. Take care.